Hello and welcome back to TechMaker. This is part 2 of building a blockchain integrated web application. In part 1 we started setting up this voter registration contract, and this is actually the test for it. I'm going to open up the contract here. So right now this contract has what you might call a security problem, because anybody can run this register function on any voter registration list and register themselves to vote. And we don't want that. You can imagine, for example, a government actually using a system like this would want to have some kind of way to validate that you actually do live in the voting district that you live in, or whatever, that you're a registered voter, that you're eligible to vote, all those sorts of things. So we need to put some sort of control on this so that not anybody can register themselves. So the first thing that I want to do is actually do a little inspection here and work through something that maybe will help you understand something. So first of all, I want to do, inside of our contract, I'm just going to set a variable of owner equals message.sender. And then, actually, no, that's not where I want to put that. So we need to define what's basically a constructor function. So we'll say function voter registration. And this is going to take no arguments for now, and it will be public. And we'll just in here set this to be owner equals message.sender. So basically what this means is whoever runs the function to deploy this contract is the one who sent the message. Anybody who calls any contract function, so like if I run it from my Ethereum address, I am message.sender. And so that's very helpful whenever we're actually trying to transfer funds and that sort of thing, because you can tell baked into the system who the person who sent the message is, or not the person, but the address rather. So in order to capture this variable, we need to come up here and say address owner. And in actual fact, I believe I want to say address public owner, which will define a function behind the scenes basically that will let us inquire as to who the owner is. So if I run truffle test again, let's just see what this says to us. So our test is still passing, obviously, because we really didn't change anything, but we're getting this message that defining constructors as functions with the same name as a contract is deprecated. That is great, because I always thought that was a really stupid idea. So let's call this constructor. Looks a little bit more like ES6, I think. Okay, let's run this and see if we get the same type of warning about something else. And it says this function is named constructor, but it is not the constructor of the contract. If you intend this to be a constructor, use constructor without the function keyword. Okay, that's interesting. Let's try that. And we'll see if it tells us anything else. This is actually very helpful warning messages. Okay, so that seems to be good. So what I want to do now is, back in our test, I want to basically say somewhere who the heck is the owner of this thing. So I'm just going to say var voter registration, or actually, sorry, I've already got that above. So we'll say owner, if I can spell, equals await voter registration dot owner, and I think I need to say dot call, and then let's just console.log the owner. Let's see what this says. Okay, so we get this address 0x627. Okay, so let's also do the following. Let's say console.log accounts 0. Okay, so those are the same addresses. So what that is telling you is that, so if we go back into our migrations file that we were looking at in the last episode, so right here we have this deployer.deploy voter registration. And what this is basically telling you is that behind the scenes, Truffle is grabbing that first address that you have when you run your test RPC, in the background again, obviously. Um, and it's using that address to deploy the voter registration contract. Um, so that's good to know. So I believe that it's also using the first address when it executes all of the functions by default. And what I mean by that is if we look back in our smart contract, I was saying earlier, when we run register, register also has a message.sender, is registered will have a message.sender. Any function you call, it's receiving that message from some address. And so I think by default, Truffle is always using the first one in the list. So that lets us do some interesting things. So we're going to write a new test. If I was following TDD perfectly, I would actually just delete all of the code that I just wrote, but it's all super simple, and I think we're just going to leave it here. I don't need these anymore, so I'm going to get rid of that, and let's write a new test. So I'm going to say it validates that only the owner can register new voters. Let's actually say it only lets the owner register new voters. That's a little bit better wording. It only lets the owner register new voters. Perfect. And then we'll say async. I'm a stickler for wording things well. I think it's important because this stuff is meant to be read by other people in theory. So it only lets the owner register new voters. Let's grab our code from here. Actually, let's think about this. So I'm going to use the registered voter example. I still need this. We'll refactor this a little bit in a little while, because I know if you are familiar with this sort of thing, you're probably going, you're duplicating stuff, and you're right. Okay, so I'm going to get the registered voter. That's a little bit wonky naming also. And I'm actually just going to call this voter for here because we're only going to have one await. Voter registration equals voter. There is registered equals await. What am I waiting on here? Oh, my text is wrapping. That's a trick. Okay. Let me actually zoom back out a bit so I get all of that on the screen. Okay, so I'm awaiting that the voter registration occurs. I'm down here. And then I want to check that he is registered. And I'm going to assert equal is registered. Okay, that's fine. Let's run this. It's going to pass, probably because it passes above, so why wouldn't it? Well, it won't because I didn't fix the variable name. So we'll run it now. Okay, so let's let that run, and I'm going to grab some coffee really quick. Okay, I'm back, and our test passed, but we really are not surprised by that, and it's because we didn't really do anything yet. So what I'm going to say in here is voter should not be registered. I want this to be false. And what I'm going to do is I'm going to run the register, and I may get this wrong the first time, but if I say from accounts for, okay, so this should fail because in fact we don't have any restriction on who can run this function yet, and I think I have this notation right, so let's just run it. But it should actually fail because it should let the person register, and then we're going to prevent that. Okay, so, and it does what we expected. Voters should not be registered. Expected true to equal false. Okay, so let's jump into our smart contract and let's fix this. So what we're going to do is in our register function. So what we can do is just write require message.sender equals owner. And we'll run this again, and this should now pass. Oh, okay. So I see what went wrong. So when we run this require, and if this fails, this is actually going to throw an exception. And you can see the word revert here. So what's basically happening is it's killing the transaction and reverting. So what we need to do is back in our test, we need to do something like, sorry if that's tiny. So I'm going to say try, and then we'll catch the error. And when we catch the error, we'll just console.log it to make sure that we're still getting that error, which of course we are. Anyway, let's run this and let's see what happens. Okay, so we still have a failing test. We're logging out the error. Oh, I see what I did. So you have to be careful when you're running these tests, because I'm saying let the voter equal account 1, but we actually set that voter up here. And I don't believe this is spinning up a new test RPC or a new chain for every test. So you have to be aware of state changes you're making to the chain in your tests. So if I set that equal to account 7, now it should tell me that this person has not been registered. Okay, so now I have 2 passing tests, and I don't want to keep that console log. I'm just going to run this to show the cleaned up version. But let's just talk through this really quickly. So basically, here I can look at this and say I've got the voter is account 7. I'm trying to run the registration from account 4. And then it's telling me, oh, nope, the person is not registered. Okay, so let's do this again. And just to basically illustrate the exact thing, okay, I don't need that, that's already there. So I'm going to set this to a variable now, because that's going to blow up if I do that way. I'm going to grab this. And as I said, this by default, you know what, for clarity, let's run this from accounts 0. This is just going to illustrate this in a more clear way. This would be the default, so we don't actually have to put that, but that way it's like very clear. Okay, so let's put that there. Say this is true, and voters should be registered. So now we're basically saying like, okay, now we're going to try to register this person again from the correct account, and that should also work. And it did not work. Why did it not work? Well, for one thing, I am making some obvious mistakes over here, so I don't actually need to do that because that guy is the same. And I do need to check this again. So that is interesting. So that should be correct now, I think, hopefully. So we're just running the voter registration again for the same voter from the different account. And then we're checking the registration again. Let me make sure that I saved it, and then we'll run this. And hopefully this actually works this time. And I can tell you that I probably need more coffee. Okay, so cool. Now we have 2 passing tests, and we are making sure that only the owner can register new voters. I think in a real voting system, this would probably be more complex. You would have a set of people who are allowed to register voters. Okay, last thing we're going to do is a little bit of cleanup in the contract. So Solidity has this cool thing called a modifier, and I'm going to put it here. We'll say modifier only owner. And I don't know if I need to give it like a public or anything off the top of my mind, but basically what you have to do is take this guy, put it here, and then put an underscore like that. And then what we can do is on register, we can say public only owner. So what this is essentially doing is the same thing. And then this underscore kind of means, okay, just keep going with whatever it's called on, right? So run this thing first, and then whatever function we call it on, just keep on going. So that should work like that. I don't know if I need anything else off the top of my head. We'll see if it gives me any warnings. Nope, seems good. So that's it for this episode. I hope you're getting a little bit more familiar with the TDD slash smart contract development process and a little more exposure to what you can put inside of a smart contract. I'm going to do a much more in-depth Solidity training series at some point. Right now, I'm just kind of getting it working, and then we're going to really focus on the web integration at some point in the future in this series. So we still have at least one more smart contract that we need to develop in the next episode or two, which will be actually creating issues and then letting people vote on those issues. One comment I wanted to make is you could obviously do this a lot of different ways. Like, for instance, voter registration could have some more complex data structures in it that let you keep multiple lists of registered voters and that sort of thing. And I think in a real world application, you would probably do that. Same thing with issues. When we get to that, you could have lists of issues that you would keep track of in one contract. And I'm not sure whether we'll do that or not yet. We're probably just going to keep it simple for the sake of this example. But anyway, that's it for this episode. In the next episode, like I said, we'll be getting into a little bit more smart contract stuff. Hopefully, we have only one or two more episodes about that. And then we will set up an application that will talk to the smart contracts. So I hope you enjoyed this. I hope you found it useful. If you're on YouTube, please click the like. It helps me out a lot. Click subscribe. And if you're on techmaker.tv, thanks for joining, and I hope you're enjoying it, and I will talk to you next time.